Ocosium presents the biodynamic power generation plant. It's necessary to achieve a power source in parallel with existing ones, able to meet the needs that are expected over the coming years. In addition, this energy must involve decreasing costs, what implies improved economic performance in enterprises and families. The biodynamic power generation plant is the first power plant in the world that emphasizes its operation on the use of energy generated in a combustion reaction to obtain electrical energy in an economical way and not harmful to the environment. The main features are fuel-based energetic materials, ammonium nitrate, fireworks explosives, low CO2 per kilowatt-hour generated, electricity generation based on technology of hydraulic turbines, emissions of gases within environmental regulations, possibility of cogeneration heat recovery. Currently, electricity is obtained from nuclear, oil, renewables such as hydrogen, solar or wind power, and energy from biomass. This graph compares the cost of generation from existing systems, power generation with biodynamics. We note that the overall costs are among those produced by combined cycle power plants and nuclear, while the annual production in megawatt-hour is always close to the values of the nuclear power plants. This chart shows the main technical data of the biodynamics power generation for 1 megawatt per hour productivity, with technical breakdown rate below 10%. The annual generation of 8,100 megawatts time stands out and generates an emission of 0.099 kilograms of CO2 per kilowatt-hour, compared to 0.40 kilograms which a combined cycle plant currently generates. Below are the energetic materials that can operate the plant with a modified ammonium nitrate fertilizer designed to obtain results in all the studies shown. Ammonium nitrate is a compound derived from ammonia. It is used as a fertilizer and as a raw material for explosives in civilian use. As an example, note that its presence in the dynamite is 50% and ANFO explosives up to 90%. Also considering the recycling of all obsolete material from military industry, unexploded ordnance or stored in an irregular way, residual material from the motor industry, especially the airbag into disuse, and all types of fireworks or signal flares. This is an important logistics and environmental advantage because you get a cheap energy source of a product considered waste and hazardous. We proceeded to calculate the energy production of the power generation biodynamic based on the following assumptions. For the calculation of the energy generated, it is assumed that gases expand in the combustion chamber from an initial volume of 12,600 cubic centimeters to a final volume of 42,000 cubic centimeters with an expansion factor of 200. Useful work generated by the expanding gases is calculated assuming an asymptotic expansion thereof, adiabatic, and no entropy change. This calculation is correct given the hypothesis from the speed of expansion after the detonation of the fuel. This useful work is used to pressurize the hydraulic circuit pressures of 10 bar and generated an average flow of 1.1 cubic meters per second. It assumes an efficiency of turbine generator set of 90%. Useful work generated would be around the 13,000 kilojoules per kilogram, generating usable energy for the load of fuel used of 0.71 kilowatts per hour. Energy being generated per hour by the plant, 6-piston 240 cycles per hour of 1 megawatt per hour. The annual production would be at values close to 8.15 gigawatts per hour, assuming 90% availability. In this graph we can see how pollution from greenhouse effect gases for biodynamic plant is about 10% of grams emitted per kilowatt-hour for the coal-fired thermal and 29% of grams emitted per kilowatt-hour for the combined cycle plant, which is the lowest carbon dioxide emissions produced. We also watch that when the rest emit sulfur compounds, biodynamic plant does not exhibit this type of issue. The same is confirmed for emissions of volatile organic compounds and nitrous oxide. This data indicate that combustion of nitrate represents an environmental advantage over other existing energy sources. Financial tables are presented for the inversion of the power generation biodynamic plant. The economic evaluation was performed according to calculation parameters on the screen. We set a return on investment in 4 years with an internal rate of return of 39.8% of the investment made. Technical information provided by Esgenia. Next, we will know the operation of the power generation biodynamic plant in general. The whole process begins with the collection and assay of raw material, which has been pre-treated by adding the additives, drying and grain size reduction by milling. A conveyor transports the material to a room where it is bonded and molded in tubular-shaped pellets of about 200 grams and 5 centimeters in diameter. The magazines are led through a circuit that goes from the cargo area to the firing area under the container of the group of cannons. The container of barrels inside houses a total of 6 guns arranged in an arc, promoting the circulation of magazines. They are immersed in water. This water circulates throughout the hydraulic circuit responsible for generation of electricity. A mechanical system loads the cannon with a simple movement up and rotating 90 degrees. After the detonation, the system returns the cannon to the circuit, in turn, to clean the barrel. The barrel is composed of 3 different parts, through which a piston runs. The lower part is the combustion chamber, which produces the detonation of the energetic material pellets. The gas explosion violently moves the plunger upward. The middle chamber is responsible for stabilizing the piston pushing speed to the proper functioning of the system. The upper chamber is filled with water to be ejected into the same container after each firing. The water container is now under a great pressure. Each gun exerts a 240 cycles per hour generation. The outer valve of the hydraulic circuit is open to deliver pressurized water to a container that balances the flow for a constant pressure distribution. This is the prototype of the first plant in the world to contain and make use of an explosion, transforming it into electricity. Some of the videos that we will see below were recorded during tests performed in Alba Monte Cristo laboratories during the years 2008-2009. Perhaps the first thing we thought it would happen is a huge roar. Indeed, the pyroelectric plant generates not the sound or the vibration of an explosion outdoor, but it's been transformed into electricity. How does the pyroelectric plant work? To produce an explosion, it's required an appropriate mix of fuels, these are the explosives, and carburants, which is the oxygen in the air. The charge is deposited and electrically detonated inside the chamber. The charge explodes, demanding oxygen, which is obtained by absorbing the outside air through a pipe to that effect. There is a massive inflow of air which is trapped at high pressure inside the pressure pots. This massive air taking produces the curious whistling you can hear in the prototype. A good example is when we breathe deeply, the air fills the lungs while we move lips to whistle. The lungs are filled and lips whistle inward. Now our lungs act like the prototype pressure pots, are filled with air. Notice how in the explosion, the air pressure expands the whole structure of the prototype. The gauges that record the internal pressure rise quickly. The needle is capable of recording up to 25 bars of pressure and reaches its top instantly. The next effect we can watch is the gradual increase of internal temperature. The plant makes use of pyroelectric high levels of temperature that the explosion chamber gains after each fire to evaporate water that will be later exploded to generate electricity. Now let's check the result of the test. The exit of air pressure is allowed and after that projected onto a turbine. The mechanical rotation is turned into electricity. Let's use some tests on a larger prototype. In this case, this is only to show the pressure that can develop a load of 50 grams for later use. The objective is to move the bar of a hydraulic cylinder, which needs at least 300 bar for that shift. If achieved, this internal pressure would be obtained with only one blast. Remember, the goal is 300 bars. Finally, the bar has been displaced with violence. Now to the pressure recorded by the gauges. We perceive that the internal pressure is reached above the recording capacity of this gauge, as its limit registration is 600 bar. Presumably, the internal pressure reached is about 1500 bar, about 5 times higher than our objective. This test verified that it is feasible to obtain an outlet pressure between 150 and 300 bar, needed to move itself from a conventional turbine or nuclear power stations. The biodynamic power generation plant is economically and technically viable. According to estimations, this technology is competitive with other energy sources used today in both cost and environmental impact. In addition to raw materials provided for optimum performance in both solid and liquid state, it is possible to use materials considered hazardous waste, such as unused airbox explosives or surplus weapons materials, and even plant biomass residues, thereby achieving not only economic value to waste but also neutralizing a hazardous material, so it could work as a recycling plant which also makes an economic profit. The evaluated energy is valid for the creation of high-pressure processes for use in reverse osmosis desalination plants.